Hey everyone, today we are looking at the last lesson of Unit 5. We're doing just a little bit more with equations, and you can see our goals say to write and solve equations to represent situations that involve rational numbers. So we're going to be looking at some of those situations here in our first activity. So it says to write an equation to represent the situation, then tell what the variable and each term in the equation represents, and then of course we're going to solve it. Now the first situation says on Monday, 1/9 of the enrolled students in a school were absent. There were 4,512 students present. How many students are enrolled at the school? Now first I'm going to think about this problem. I want to understand what's going on. We definitely have some key information here. So it tells us on Monday, 1/9 of the enrolled students were absent, missing, and 4,512 were present. So if I'm thinking about this, I know that the students enrolled at the school should be greater than this because some part of that um, population of the school was missing, was absent that day. So now if I create an equation, remember in equations, we are trying to we're trying to make both sides of it equal to one another. So if one side of the equation, is represented by the number of students that are there, then the other side of the equation has to represent that. So it has to show the students there with the missing amount. And if 1/9 are missing, so we don't know how many students should be there, but we do know that they were missing 1/9 of those students. So this would be one way to write this equation, but this is a little more complex than we really want to be. So if you think about it, and this goes back to what we talked about with percentages, we talked about, if you're buying an item that's 30% off, you're really paying for 70% of that item's price. So you take 100% minus the 30. That's kind of what's happening here. We're taking 100% or one of the student population of the school, and we're taking away 1/9 of that student population. So really what we're looking at here, if 1/9 of the student population is missing, is we're looking at taking this and combining it into what's there, the 8/9 of the student population. So what I think a better way to write this would be is to write it as 8/9 of the student population is equal to what was there that day. Now, if we have to solve it, we would use the inverse operation. So instead of multiplying here, we're going to divide both sides by 8/9. I'm going to divide 4,512 by 8/9, and that'll tell me that the actual student population, make sure it's more than what was there that day, is 5,076 students. Okay? Now for the next one, a hiker begins at sea level and descends 25 feet every minute. How long will it take to get to an elevation of negative 750 feet? So let's write that equation. Let's make one side of the equation that total that we're trying to get to. The way the hiker gets there is every minute descending, that's an important word there, descending 25 feet every minute. This should really be represented by negative 25 feet per minute. So we're going to take that times what's missing here in the equation, how long, that's going to be our variable. Every minute, the hiker descends 25 feet, and that'll get us to the elevation that we're trying to get to. To solve this, we use the inverse operation. Again, we're multiplying, so we need to divide both sides by negative 25. And when we divide negative 750 by negative 25, we will get the number of minutes it would take to get to that height, which is going to be a positive number of minutes, 30 minutes. Now, lastly, Jada practices the violin for the same amount of time every day. Same amount of time every day. On Tuesday, she practiced 35 minutes. How much does Jada practice in a week? All right. So we need to, taking the time that she practiced on Tuesday, and remember it told us the same amount of time every day. So we just need to increase that to represent 1 week. Now, the easiest equation to write for this would be to take our time times the days of the week, 7 days. I would put that in parentheses here to show that being multiplied. And that's going to equal the amount of time she practices in a week, which we don't know. So that's going to be our variable. We use P for practice. So that would be an equation that would represent the situation. Now, it looks a little different because we don't usually have our two numbers being multiplied here. But truthfully, it's okay. And if we just multiply them, we'll have the amount of practice time equal to 245 minutes. And in a question like this, I'd want to make sure that it didn't ask for an answer in hours or something that's trying to trick me up a little bit. Okay? On to the next activity. It says a balloon is floating above a lake and a sunken canoe is below the surface of the lake. The balloon's vertical position is 12 meters and the canoe is negative 4.8 meters. The equation 12 plus d equals negative 4.8 represents the situation. The question asks, what does the variable represent? Well, there's nothing wrong with drawing a picture here. So if we have a balloon, so this would be a good vertical number line situation here. If we have a balloon that's 12 meters, and that's the balloon, and we have a canoe that's negative 4.8 meters, canoe, and it's negative because it's below the water's surface. So I need to represent the water surface, which we would represent with 0 here on my number line. It needs to be closer to the bottom. If you look at our intervals here, we're going up to 12 on this side and down to about 5 on this side. So 0 is going to be the water surface. And then it wants to know, what does the variable represent? So let's look at that equation. Well, the 12 in this equation would have to represent the balloon height. The negative 4.8 would represent the canoe's height, the canoe's elevation, which is below the water. So D would have to, if it's going to take us from 12, if we add whatever the D value is, it's going to get us to this point. It's telling us the distance between the balloon and the canoe. That is what the value represents, what the variable represents. The distance between balloon and canoe. Then it wants the value of D to make the equation true. Well, we could solve it. Let's solve that equation. So I'm going to use my inverse operation. We're using addition in the equation. The inverse of addition is subtraction. So instead of adding 12, I need to subtract 12 from both sides. That will keep it balanced and equal. When I take away 12 after adding 12, that'll cancel, which is what I want. And to find the value of D, I just need to combine these two negative amounts to get negative 16.8 meters. All right, moving on to the back of the sheet. It has you match, 6 different situations with their different representations on a number line. Now notice the number lines are pretty much the same, numbered the same, but we have arrows going some in different directions, some going the same direction, some only have one arrow and a dot on the number line. But let's look, we're going to do the first one together, then I would like you to match up the rest before checking with the answer key here at the end. So let's look for our first situation. A penguin is standing 3 feet above sea level and then dives down 10 feet. What is its depth? So in this number line, I'm going to look for an arrow that's moving to the right to go above sea level, to go in the positive, and that's going to go to the right, and then dives down 10 feet is going to go down in the negative. So I'm looking for a number line that has arrows going in opposite directions, to the right and to the left. And I see one here, here, and that's it. So it's either 1 or 4, I believe. For 1, starting at 0, it goes up to 3. So that would represent the 3 feet above sea level. And then from that point, the penguin's going to dive down 10 feet. So let's see if the length of this arrow is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it stops where the solution to this problem would be at -7 feet. So definitely 1 is a representation of situation A here. Would you go ahead and find the match for the rest of these situations with the remaining number lines? Again, check with the answer key when you finish to see if you did it correctly, and then take a look at the practice problems for lesson 16. Everybody have a great day.